Okay, so here's a video on the definition of a parabola. That's what we call today's lesson. And I figured I'd start off with the notes. In case you need them, you should have these written down already. A parabola is a locus of points, a collection of points, that are equidistant from a focus point and a directrix line. Now, the definition is what allows us to find the equation because it's only with the equivalence of these two being equidistant that allows us to set y equal to the distance formula, etc., etc. You'll see if you're not comfortable with that. I'm going to do an example now. Now, here are the steps. These are the steps that I recommend you use. So I'm going to go back and forth between these, and I'm going to check them off as I do them. Now, if you don't have these written down, you should have them in your notes. I'm going to pick a question from the page that won't spoil your homework questions. So let's pick an example like question number 7. Okay, so it says derive the analytic equation. They're saying find the equation, so that's what my answer looks like, of a parabola given the focus of 2, 4 and a directrix on the x-axis. Okay, so let's go through step by step. Draw the axes and focus point. So this is question number 7. All right, I draw the axes. And I'm going to put my focus point on the graph. Now the focus point is 2, 4. So how do I do that? I go, all right, 1, 2, 1, 2, 3, 4. And the thing you need to remember is that none of this needs to be exact. The drawing is just to allow us to understand the context. So this is my point, 2, 4. And I'm going to erase these lines because I like my work to look clean. That's our focus point. Now I'm going to boldly draw the directrix line. Here's orange. They told me that the directrix line is the x-axis, so that means this is the directrix. That's done. That's done. Now I have to draw a curved parabola that bends around the focus point starting in the middle. All right? So my parabola is going to start in the middle, right in the middle of these two, and it's going to bend up and around the focus point. It doesn't matter how good this looks, because this is not an art class. My parabola is drawn. I'm going to place an arbitrary point x, y on the parabola. So let's zoom in a little here. I place my arbitrary point, meaning it can go anywhere. I'll just put it over here. This is my point x, y. Now we need to determine the equations for both distances. What I mean by that is I need to figure out what formula represents this distance here. I'll make solid. This distance. And what formula represents this distance. Now the vertical line is always going to be equal to y as long as the directrix is the x-axis. Here's why. If I was to graph this point x, y, I have to count over x values, right? So whenever you graph a point, you start here and you move over You go, all right, 1, 2, 3, 4, whatever, x, right? Because that's the x value of that point. And then you count up, you go, all right, 1, 2, 3, 4, whatever, y, because y is the y value of that point. So essentially what I'm saying is, if this was like 2, 4, like the focus point is, or if it was like 3, 9, then this would be 3, and this would be 9. If it was something like 15, 17, that would mean this is 15 units here, and this is 17 units here. But since we're using an arbitrary point, x comma y, it means that that line must be equal to y. I'm going to clean this up a little bit. So I know this equation, this one's fine, I'm good. The other line is going to require the distance formula. From the focus point to x comma y is going to require us to plug in to the distance formula, which is distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. What this is this is the change represented by a triangle. This is change in x, and this is the change in y. This all derives from the Pythagorean theorem, but if you really are interested in learning that, you should come to office hours. Now, what we need to do is we need to identify which one of these points is point 1 and which one of these points is point 2. It doesn't really matter. It doesn't matter at all. You're going to get the same answer either way. I like to just do it to keep my work neat. So I'm going to say, all right, well, point 1, let's make that 2, 4. That's our point, right? 2, 4. Point 2, that's going to be the point x comma y. Since this is point 1, that means this is x1 and this is y1. Since this is point 2, that means this is x2 and this is y2. So when I go to plug in, I'm going to keep that into account. The 2 goes in for x1, and the 4 goes in for y1. X is x2, and y is y2. Now we're going to bring down the rest of the equation. Give myself a little space because I'm getting crowded here. When we bring down the rest of the equation, I'm talking all the other pieces. Now this is the formula for the distance here. But based on the definition of a parabola, this line and this line are congruent. They're equal. So that means that this equation is equal to y. Now I want to create a formula for an equation, and in order to get that I need to have y equals. I like y equals here, but then there's a y here, and I'd really love it if I could combine some like terms. So what I'm going to do first is I'm going to unpack all of this stuff under here. The way to do that is to get rid of this square root. How do you get rid of a square root? With a square. I have to do it to the other side to balance it out. The square and the square root will cancel out on the left. So now when I rewrite, I have x minus 2 squared plus y minus 4 squared is equal to y squared. Both of those binomials being squared, this guy here and this guy here, these are both going to be box methods. If you're not sure why, I'll show you. This right here means x minus 2 times x minus 2. How would you multiply that? A box method. X minus 2 and x minus 2. I'll show you one, but the other one I'm going to use the mental shortcut for. So this is negative 2x. This is 4. X times x is x squared. And bottom left is negative 2x. So when I bring out these terms, I'm going to get x squared minus 2x plus 4. So that's what this whole thing was equal to on the left-hand side. This guy in the middle, I already know what it's going to be equal to, so I'm just going to bring it down. Y squared minus 8y plus 16. And now we can bring down the other term, equal y squared. So it expands, it gets big, it gets messy, but it gets simple again in a second. Here's what I can do. I want to move over the y squared. Oh no, they both cross out. What I get now is x squared minus 2x plus 4 minus 8y plus 16 equals 0. I got some like terms here, might as well simplify those. Plus 4 and plus 16, that's plus 20. And I really want to get y by itself, that's still my goal. So I'm going to add 8y to this side, and add 8y to this. I get x squared minus 2x plus 20 equals 8y. In my last real step, I divide every single thing by 8 in order to cancel this out. So when I write my final answer, I say y equals x squared over 8 is 1/8 x squared. Negative 2x over 8 is negative 1/4 x. 2 over 8 becomes 1 over 4. Got it? And now 20 over 8 can be simplified as well. Divide them both by 4. And I get plus 5 over 2. And that's what my final answer looks like. That is the equation of the parabola that is equidistant between the x-axis and the point 2, 4. Okay? So just follow the steps. You'll find an equation, simplify it, make it look the same way that I did, and you'll be totally prepared for when this pops up on a Regents or on a test.